The night sky has always captivated humanity. For centuries we've looked up in wonder, our imaginations sparked by the twinkling lights above. We gaze up at the stars and wonder about the vastness of the universe. Each star, a distant sun, each constellation, a story written in the sky. Every so often the heavens offer us a special treat. Meteor showers streak across the sky, leaving us in awe of their fleeting beauty. In the UK, we might be lucky enough to witness the Northern Lights. This natural phenomenon is a rare and magical sight. This breathtaking display of light and color dances across the sky. The vibrant greens and purples create a mesmerizing spectacle. It's a rare event, but it leaves a lasting impression on those fortunate enough to see it. The memory of such a sight stays with you forever. The Northern Lights are not a common sight in the UK. Most nights our skies remain calm and starry without the vibrant display. They are typically associated with more northern countries like Norway and Iceland. These regions are known for their frequent and vivid displays. However, recent solar activity has increased the likelihood of seeing them further south. This has brought the Northern Lights closer to home. This has led to a surge of excitement and anticipation among skywatchers across Britain. Communities gather, hoping to catch a glimpse of the lights. The chance to witness this celestial wonder from our own backyard is an opportunity few want to miss. It's a moment of shared wonder and awe. The science behind the Northern Lights is as fascinating as the display itself. These mesmerizing lights, also known as the Aurora Borealis in the Northern Hemisphere, have captivated humans for centuries. It all starts with the sun, our very own star. The sun is a massive ball of hot plasma, constantly undergoing nuclear fusion. The sun constantly emits a stream of charged particles known as the solar wind. This solar wind is composed mainly of electrons and protons. These particles travel through space at incredible speeds, sometimes reaching up to 900 kilometers per second. Sometimes the sun releases a more intense burst of particles in an event called a solar flare or a coronal mass ejection. These events can release as much energy as billions of atomic bombs. When these charged particles from the sun reach Earth, they interact with our planet's magnetic field. This interaction is crucial in creating the Northern Lights. The Earth's magnetic field acts like a shield, protecting us from the harmful radiation of space. It deflects most of the solar wind away from the planet. However, some of these charged particles are guided by the magnetic field lines towards the poles. This is why the Northern Lights are most commonly seen near the Arctic and Antarctic regions. These particles then collide with atoms in our atmosphere, primarily oxygen and nitrogen. These collisions release energy in the form of light, creating the beautiful and colorful displays we know as the Northern Lights. The collisions between the charged particles and atmospheric gases create the stunning array of colors we see in the Northern Lights. These lights, also known as the Aurora Borealis, are a natural light display predominantly seen in high-latitude regions around the Arctic and Antarctic. The different colors are determined by the type of gas involved and the altitude at which the collision occurs. Each gas emits a different color when excited by the charged particles. The most common color seen in the aurora is green. This green light is produced when charged particles collide with oxygen molecules at lower altitudes, typically around 60 miles above the Earth. Green is produced when charged particles collide with oxygen at lower altitudes. The green hue is the most visible and often the brightest part of the aurora. Higher up in the atmosphere, oxygen can also produce red light. This red light occurs at altitudes above 150 miles and is less common but equally stunning. Nitrogen, on the other hand, is responsible for the blue and purple hues that are sometimes visible. These colors are produced when charged particles collide with nitrogen molecules at various altitudes. The mixture of these colors creates the mesmerizing dance of light that we call the Aurora Borealis. This natural phenomenon continues to captivate and inspire people around the world. Section 4. Seeking the Northern Lights. The Northern Lights are elusive and unpredictable, but there are some things you can do to increase your chances of witnessing this celestial ballet. Firstly, you need to be in a location with minimal light pollution. Cities and towns cast a bright glow that can obscure even the most vibrant auroras. Secondly, you'll want to find a spot with a clear view of the northern horizon. The northern lights typically appear as shimmering curtains of light hanging down from the sky. Finally, it's important to be patient. The aurora can appear and disappear quickly, so be prepared to wait and watch. Section 5. Northern Lights over the UK. In recent weeks, the UK has experienced a surge in Northern Lights sightings. This is due to a period of increased solar activity, which has sent more charged particles towards Earth. On March 8, 2025, the Met Office reported potential Northern Lights sightings in northern Scotland. This sparked excitement among skywatchers across the country. While cloud cover may have obstructed the view for some, others were treated to a rare and unforgettable display. These sightings serve as a reminder of the dynamic nature of our planet and the awe-inspiring phenomena that occur high above us.